Good morning, students. This is the Vikas Global Institutions Engareddigudam. Last class I was discussed about the limitations of thermodynamics and some objective bits on thermodynamics. So today continue some objective bits on thermodynamics. So in volume 2 chemistry, page number 173, classwork exercise 1, which is an irreversible process. Which is an irreversible process. Irreversible process. Option 1, mixing of two gases by diffusion. Number 1, mixing of two gases by diffusion. So what is the diffusion? We know the diffusion in the last class in the states of matter. Number 2, evaporation of water. Evaporation of water at 373 Kelvin and 1 atmosphere pressure. This is option 2. And option 3, dissolution of NaCl. Dissolution of NaCl in water. NaCl in water, option 3. And option 4, burning of coal. Burning of coal. These are the 4 options. We will give you one question, that is, which is an irreversible process? Which is an irreversible process? We know the reversible and irreversible. So what is the reversible and irreversible? Last class I was discussed about the reversible and irreversible. So first of all, so once again I will repeat it: reversible and irreversible. So what is the meaning of reversible? What is the meaning of irreversible? Reversible. What is the reversible? It is the slow process, and irreversible is the fast process, and also called spontaneous process, and also known as spontaneous process. It occurred, reversible process occurs the number of times, infinite steps. But whereas in the irreversible process is the finite steps, finite time. So here, what is the question? Which is an irreversible process? Which is an irreversible process? Irreversible process means fast process or spontaneous process. We have the 4 options. From the question: mixing of two gases by diffusion. We know the diffusion in the states of matter, and evaporation of water at 373 Kelvin and 1 atmosphere pressure, and third one, dissolution of NaCl in water, burning of coal. Here the 3 options are. Chudana once again ఒకసారి క్వశ్చన్ చూస్తున్నానన్న. Which is an irreversible process? We have the 4 options and also give 4 options. One is AB and 2 is BC. B, C means ఎలా ఇద్దాం దీనికి ABCD అని ఇద్దాం. 1 to 4 అనుకుండా ABCD అని ఇద్దాం. Okay, and second is the BC, and third one is the ABC, and fourth one is the ACD. Okay, nana, small mistake. So which is an irreversible process? Mixing of two gases by diffusion, evaporation of water at 373 Kelvin, 1 atmosphere pressure, dissolution of NaCl in water, and burning of coal. And here the 4 options: AB, BC, ABC, ACD. Okay, among these 4, 1, 2, 3, 4, which one is the correct? So here, mixing of two gases by diffusion is easily process, fast process, spontaneous process. Just mixing of the two gases, it's a fast process. Evaporation of water at 373 Kelvin and 1 atmosphere pressure, it is a slow process. Why? Evaporation of water at 373 Kelvin. We heat the water up to 373 Kelvin. మనం వాటర్ నుంచి 373 Kelvin వరకు హీట్ చేసుకుంటూ వెళ్ళాలి. అప్పుడు ఎవాపరేషన్ అవుతుంది అంటున్నాడు. That is the slow process. And next one, dissolution of NaCl in water. We take the NaCl and simply dissolve in water. That is a slow process. Okay, sorry, fast process, spontaneous. And burning of coal, just we burn the coal easily. That is a fast process. This is a fast process. Burning of coal is a fast process. Dissolution of NaCl in water is a fast process. Evaporation of water at 373 Kelvin is 1 atmosphere is a slow process. And mixing of gases, two gases by diffusion, just mixing of two gases is also a fast process. And among these four options, here the A is the irreversible, C is the irreversible, and D also irreversible. Here A, C, D is the irreversible process. Here where it is, one is the AB, two is the BC, and third one is ABC, and fourth one is the ACD. And among these four, which one is the correct? And fourth option is the correct, that is the ACD. Clear, Nana? Okay, thank you. Next one. Next one. Delta U is equal to 0. Delta U is equal to 0 for. Delta U is equal to 0 for. Number 1. Cyclic process. Cyclic process. Adiabatic process. Cyclic process. Adiabatic process. Option 2. Isothermal. Isothermal adiabatic. Isothermal adiabatic. Option 3. Cyclic isothermal. Cyclic isothermal. And option 4. Isochoric. Isochoric and isothermal. Isothermal. Okay. So, chodana, delta U is equal to 0. We know the all types of thermodynamic process. One is the isothermal process, adiabatic process, isobaric process, isochoric process, and cyclic process. So, what is the isothermal process? What is isothermal? Once again, I will repeat, Nana. What is isothermal? Temperature is the constant, delta T is equal to 0. Here E or U means internal energy is the 0. We write the delta E or delta U. We write the delta E or delta U. Internal energy represented as E or U. Here the isothermal process, delta T is equal to 0 and here the temperature is the constant. So, internal energy is a 0. And next one, adiabatic process. What is adiabatic? Here the heat flow is the constant. So, Q is equal to 0, adiabatic. And isobaric. So, isobaric is the pressure is the constant, delta P is equal to 0. And isochoric, these are all important, many important, most important bits in the thermodynamic process. It is so many times repeated. So, isochoric process, here the volume is the constant, delta V is equal to 0. And cyclic process. Here the cyclic process initial state regain after some operation, that is called cyclic process. Here delta U is equal to 0 and delta H is equal to 0. So, last class I was discussed about the total isothermal thermodynamic process. Here the isothermal is the delta T is equal to 0 and also delta E and delta U is equal to 0. Adiabatic Q is equal to 0. Isobaric delta P is equal to 0. Isochoric delta V is equal to 0. Cyclic process delta U and delta H is both are 0. Okay, Nana? Here based on these points, here delta U for cyclic process yes, but the adiabatic is wrong. Cyclic is okay, but adiabatic is wrong. And isothermal adiabatic, isothermal okay, adiabatic wrong. And cyclic okay, isothermal also okay. Why? The isothermal delta U is equal to 0, cyclic delta U is equal to 0, delta U is 0 for. Okay, and fourth one, isochoric is wrong, isothermal is okay. And among these four options, which one is the correct? That is the cyclic delta U is equal to 0 for cyclic and isothermal process. Okay, Nana? Next one. Next one, boiling water. Boiling water in a closed steel tank. Closed steel tank is an number 1 closed system, number 2 insulated system, number 3 open system, number 4 adiabatic system. Adiabatic system. Okay, so which one is the correct? Boiling water in a closed steel tank is an, we know the open system, closed system, isolated system. Among these 4 options, boiling water in a closed steel tank, that is the we take the one closed open tank. This is the open system. A closed with the lid, the tank, that is called closed system. So, amongst boiling of water in a closed steel tank is an closed, insulated, open or adiabatic. Which one is the correct? That is the closed system is the correct. Boiling water in a closed steel tank is an closed system. Okay, Nana? Okay. So, now stop the objective bits. Now, I will discuss about some topics. Okay, so that is the energy transformations. So one is the heat. So what is the heat? It is another form of energy transformation. That is the one is the heat, and next one internal energy, enthalpy, work, and Gibbs energy, entropy. Some topics are there in the thermodynamics. Now I will start about the heat energy. Heat. It is a form of another energy. It is a form of energy. It is a form of energy. Heat flows from high temperature to low temperature. Heat flow from high temperature to low temperature. Here, heat flows from one system to another system. In difference in temperature. So what is the heat? It is another form of energy. Heat flows from high temperature to low temperature, or heat flows from one system to another system by difference in the temperature. Okay, Nana? Clear? It is represented by the Q. Heat represented by the Q, small q or capital Q. Anyone we represent, but most of them are represented by the small q. It is another form of energy. It represented by the Q. Heat flow from one system to another system by temperature difference. Difference in temperature. Okay, Nana? So, sign of Q. What is the sign of Q? So, any system, we absorb the energy from the surroundings. It gives the positive sign. When we will give the positive sign of the heat, eppudu manam heat ki positive sign icham. When the heat absorbed by the system from the surroundings, in chesina system anedi surroundings nunchi heat ni absorb chestundi. So it give the positive sign. But why when will we give the negative sign? So heat release the system to the surroundings. It gives the heat gives the negative sign. Clear Nana? Sign convention of the Q. Once again I will repeat it. So heat absorbed by the system from the surroundings, it gives the positive sign. Positive sign. Okay. In case when the heat released system to the surroundings, it gives the negative sign. Okay, Nana? Clear? So next one, units of Q. Units of Q. Generally, the Q is measured in terms of calories. In terms of calories. Generally, it expressed as a joules. Generally expressed as a joules, but measured in calories. So simply we write the 1 calorie is equal to 4.184 joules. 4.1 calorie is equal to 4.184 joules. Clear Nana? Okay. Okay, clear Nana? Units of Q. Generally, the Q heat is measured in terms of the calories, but expressed in terms of the joules. We write the 1 calorie is equal to 4.184 joules. But here heat is the state function or path function. Heat is the path function. So already last class I was discussed about the heat and work are path functions. Why heat is the path function? Why heat does not accept as a state function? Enduku accept state function kinda ante here the heat is the not a state function because does not obey the initial and final, does not contain initial and final states, or simply does not give state of the system. Okay, clear Nana? So why heat is a path function? Why it is not a state function? Why? Heat is a path function. It is not a state function. Why? Here heat does not give initial and final state. So it is not a state function. It is a path function. Clear? It is a path function. It is a path function. Clear Nana? Okay. Next one, internal energy. Next one, internal energy. Heat okay Nana? Next one, internal energy. It is also known as the internal energy. It is also known as change in thermodynamics. Change in thermodynamic energy. Change in thermodynamic energy. Change in thermodynamic energy. Change in thermodynamic energy. Internal energy, it is also known as change in thermodynamic energy. It is the internal energy is the sum of all types of potential and kinetic energies. Kinetic energies of constant particles at a given temperature. So what is the meaning of internal energy? The internal energy is the sum of all types of potential and kinetic energy of the potential and kinetic energies of the constant particles at a given temperature is called internal energy. The internal energy, it is represented as either E or U. E or U. Ela em represent chesukovachu. The internal energy represented by the E or U. Okay. Here E is either state function or path function. It is the state function. Internal energy is the state function. And extensive property. Extensive state function and extensive property. Why it is called internal energy. Why? It accepts the state function extensive property. So here internal energy contains change in the energy. Okay. Why it accepts the state function? Why it acts as a state function and extensive property? Here the state function, what is the meaning of state function? That any system accepts the initial and final states. Here the internal energy contains initial and final states. So it is called state function. State function. It is also called a extensive property. Okay. It is so simply internal energy is a state function and extensive property. Okay, and next point, internal energy does not calculate absolute value of the E. Does not calculate absolute value of the E. But we determine the change in the internal energy. We determine the change in the internal energy by first law of thermodynamics. Based on the first law of thermodynamics, we determine the change in the internal energy, but we cannot calculate absolute value of the V. We cannot determine the absolute value of the internal energy, but we determine the change in the internal energy. Here delta E means or delta E or delta U, we write the any one, delta E or delta E. Here we write the delta U. What is the meaning of delta U? Change in the internal energy. It is the internal energy, it is a change in the internal energy. We cannot calculate the absolute value of the E, but we can determine the change in the internal energy by the first law, based on the first law of thermodynamics. So what is the delta U? It is a U final minus U initial. U final minus U initial. Okay, Nana? So delta U is equal to U final minus U initial. It is a heat content. It is a heat content of system. Heat content. It is a heat content of system. It is a heat content of system at constant volume. At constant volume. So we write the delta U is equal to. We write the delta U is equal to. We write the delta U is equal to QE. Heat content at constant volume. Delta U is equal to QE. So delta E is a change in internal energy. It is a heat content in the system at constant volume. So we write the delta U is equal to QV. Clear? Okay. Internal energy we represented by the E or U. It is a change in the thermodynamic energy. It is also known as change in thermodynamic energy. It is some of the potential, some of the total types of potential and kinetic energies of the at given temperature is called internal energy. It is a state function and extensive property, not a path function. It is a state function and extensive property. We cannot determine the absolute value of the V. We can determine the change in the internal energy based on the first law of thermodynamics. So what is meant by delta U? Here the delta U is equal to U final minus U initial. It is the heat content of system at constant volume. So we write the delta U is equal to QV. Okay, and next one. Enthalpy. Next one, enthalpy. Third one is second one is internal energy and third one is the enthalpy. Enthalpy. So what is the enthalpy? Here enthalpy. So what is meant by it? It is a measurement. It is measurement. It measures the total heat content in the system at constant temperature and pressure. What is that? At constant temperature and pressure. At constant temperature and pressure. So what is the enthalpy? Enthalpy is a measurement. It measures the total heat content in the system. Total heat content in the system at constant temperature and pressure. That is called enthalpy. The enthalpy, it is represented by the H. It is represented by the H at constant temperature and pressure. Okay, it is a measurable. It is a measurement. It measures the total heat content in the system. So, you give the one formula by Clausius and his scientist ఈ ఎంథాల్పీకి ఒక ఫార్ములా ఇచ్చాడు. దట్ ఈస్ H is equal to U plus PV. H is equal to U plus PV. That the clashes give the one formula by enthalpy. Enthalpyకి clashes అనే scientist ఒక ఫార్ములా ఇచ్చాడు. That is H is equal to U plus PV. So what is the internal energy? ఇక్కడ ఏమన్నాం, it is the heat content of system at constant volume. Here enthalpy is the measurement, it is the measure the total heat content in the system at constant temperature and pressure. Based on that point, based on this point, heat content of system, heat content of system, the given classes give the one formula, that is H is equal to U plus P. Here H is the enthalpy, U is the internal energy, and PV is the P constant, V also constant. H is equal to U plus PV. So same as in the internal energy, we cannot determine the absolute value of the enthalpy. We cannot determine the absolute value of the enthalpy. We can determine the change in enthalpy. We can determine the change in the enthalpy, H final minus H initial. We can determine the change in enthalpy. Cannot determine the absolute value of the H. Absolute value of enthalpy. We can determine the change in the enthalpy. Okay, we write the formula by at constant pressure. We write the formula at constant pressure. We write the formula by at constant pressure. So change in enthalpy, we write the change in enthalpy at constant pressure. Delta H is equal to delta U plus P delta V. Is the change in the enthalpy at constant pressure. Change in enthalpy at constant pressure. Clear? It is the state function, not a path function. It is a state function because of it depends upon the initial and final states. It depends upon the state of the system. So it is a state function. It is a state function and extensive property. So what is the meaning of extensive property? Depends upon the total amount of the substance. Here the internal energy and enthalpy both are state functions and extensive properties. So this is the enthalpy. So once again I will leave it total heat, internal energy and enthalpy. So danto stop chestanu nenu. So what is the heat? It is another form of energy. It is a flow from high temperature to low temperature, or heat flow from one system to another system, difference in temperature. That is called heat. It is flow from one system to another system, difference in temperature. It is called heat. It is represented by the small q or capital Q. Anyone we give the heat, Q or small q or capital Q. It is a sign of Q. When we will give the positive sign and negative signs of the heat. Eppudu manam positive sign istam, negative sign istam. Here the system, heat absorbed by the system from the surroundings. Heat absorbed by the system from the surroundings, it gives the positive sign. Heat released by the system to the surroundings. ఇక్కడ ఏం చేస్తుంది, సిస్టమ్ అనేది హీట్ని అబ్జర్వ్ చేస్తుంది, దట్ ఇస్ అ పాజిటివ్ సైన్. హీట్ రిలీజ్ చేస్తుంది సిస్టమ్ సరౌండింగ్స్కి, దట్ ఇస్ కాల్డ్ నెగటివ్ సైన్. క్లియర్? సైన్ ఆఫ్ క్యూ అండ్ నెక్స్ట్ యూనిట్స్ ఆఫ్ క్యూ. జనరల్లీ the heat measured in terms of calories but expressed in terms of joules. So 1 calorie is equal to 4.18 joules. It is a path function, so not a state function. Why? Heat does not give initial and final state, does not depends upon the state of the system. So it is a path function, it depends upon the path. So it is a path function. And next one, internal energy. So what is internal energy? It is also known as the change in the thermodynamic energy. It is the sum of the all types of potential and kinetic energy of the constituent particles at a given temperature. It is a sum of all types of potential and all types of energies like potential and kinetic energies at constant particles at a given temperature is called internal energy. It is represented by the ERU. It is a state function and extensive property. It depends upon the state of system. It contains the initial and final state. So it is a state function and extensive property. Here extensive means it depends upon the total amount of the substance. So it is an extensive property and state function. We cannot determine the absolute value of the internal energy. We can determine the change in the internal energy based on the first law of thermodynamics. So what is meant by E delta E delta U? E delta U is equal to U final minus U initial. It is a heat content of system at constant volume. It is a heat content of system at constant volume. So we write that delta E is equal to QV. Heat is the at constant volume. Okay. And next one, enthalpy. So what is the enthalpy? It is a measurement. It measures the total amount of heat present in the system. It is a measurement. It measures the total heat amount present in the system is called enthalpy. At constant temperature and pressure is called enthalpy. It is a measurement. It measures the total heat content present in the system at constant temperature and pressure is called enthalpy. It is represented by the H. It gives the formula by Clausius. So H is equal to U plus PV. It is the formula of the Clausius enthalpy. H is equal to U plus PV. Here H is the enthalpy, is internal energy, PV is the pressure and volume. So we cannot determine the absolute value of the H. We can determine the change in the enthalpy. Here the delta H is change in enthalpy. There is a U final, H final minus H initial. So at constant pressure, we write the change in enthalpy. We write the change in enthalpy at constant pressure. That is the delta H is equal to delta U plus P delta V. It is a state and state function and extensive property. Why? It depends upon state of system. It contains the initial and final states. So this is total about the today class. There is a heat, internal energy and enthalpy. Tomorrow I will continue. Thank you, students.